Okay, this is the first day of our new unit, and we are going to be talking about factoring. So today we're going to do it by GCF, our greatest common factor, and by grouping. So factoring is the process of breaking up a polynomial into smaller pieces of your factors. You're essentially like unmultiplying the polynomial, so going backwards from what you're used to doing. So greatest common factor, GCF, is the largest number and or variable that all factors of your expression have in common. So to find the GCF, you first want to find the prime factors of each term. Okay, and then you're going to circle the common factors and multiply them together to get the GCF. And you may at some stage not feel like you have to go all the way down to the prime ones, but let's at least start there, and we'll go from there. So we got 24. So you're like, how do I break up 24? And you can even do that tree like we did before. Well, 24 breaks up into 2 and 12, and then 12 breaks up into 2 and 6, and then you got 2 and 3. You want to say the same thing with 42. Well, 42 breaks up into 2 and 21. 3 and 7 is 21. So then you're looking, your prime factors here is 2 times 2 times 2 times 3, right? That's easier for you to write out. You can think about it as 2 cubed times 3. This one here is 2 times 3 times 7. So what do they have in common? They just have a 2, right? And they also have a 3 in common. So your GCF is 2 times 3, or in this case, our GCF is 6. Okay, so let's think about this. And you can either write it out like that if you want, or sometimes it may just be easier to be like 4x squared y cubed. Well, 4, the prime factors of 4 are 2 times 2, and then x squared is x times x, and then y cubed is y times y times y. Whereas 6x to the fourth y squared is 6x to the fourth y squared. 6 is 2 times 3. That's 4 x's being multiplied and 2 y's. So you've got a 2, you've got a 2 in common. You've got an x, an x, an x, an x. Can I circle any more x's? Well, no, because there's no more on the top, even though there are some on the bottom. And then y's, you're seeing how many match up. Okay, so we noticed our 2 matches, so our GCF has a 2. And then we got 2 x's, so that's x squared. We got 2 y's, so that's y squared. Okay. So, I mean, you could have broken it down, though, and said, hey, 4 and 6, the GCF is 2. The greatest thing I could pull out of both of them is 2. X squared and x to the fourth, well, that's x squared. X cubed, y squared, that's y squared. And apparently that example didn't copy, so let's just go ahead and make one up. Maybe I say that it is, let's do 15x y squared, and then 5xy. Okay, so with 15, you want to think about what that GCF is going to be. So you got a 3 times a 5 times an x times y times y. And 5xy, those are all already prime, so it's 5 times x times y. So we got a 5 in common, an x in common, and a y in common. So that means our GCF here is 5xy. Okay. We need to be able to find the GCF because that's about what we're going to use to factor. So let's keep that in mind as we look at these next examples. So find the GCF of all these terms. That's what we're going to do as we look down here. That's mere step, first step. Then we're going to divide the polynomial by that GCF. The quotient, so the remainder, is going to be our other factor. And we're going to express the polynomial as a product of the GCF. And I don't know, you can say about the quotient or like the remainder, however you want to think about that, but the result we get after dividing. Okay, so as you look down here, you want to think about 2 and 7. So what's the GCF of 2 and 7? Well, there's nothing you can common there. You can't pull anything out, so that's just like 1. So our GCF, that's a 1 for the number. I've got an x squared and I've got an x. So what's the biggest thing they have in common? Well, just 1x. I don't have any y's here. I've got a y here, so can I pull y out? No, they have to have in common, meaning the same. So we're going to take our GCF, which is 1x, and we're going to divide the polynomial by that GCF. So we're saying, hey, I'm dividing, and I think that's actually maybe easier for you to think about it, dividing it separately, but you could also put it all under one big divide sign. We're dividing by 1x and by 1x. So 2x squared divided by x, 2 divided by 1 is just 2. Okay, x squared divided by x is x. And then negative 7 divided by 1 is negative 7. X divided by x cancels. Maybe I should have crossed that out when it cancels. And then we got a y left over. So that is definitely not the same as what we had to start with. But we're saying, hey, our polynomial is the product, so we're multiplying this, and then we usually put our GCF out front. So x out front. So we're saying, hey, x times the quantity of 2x minus 7y is equal to what we got up there. If you don't believe me, go ahead and stop the video. Try distributing. You should get what we started with. Okay, let's look at the next one. The first thing you want to think here, when you got 16x cubed, 12x squared plus 4x, is you want to think about what's the GCF. Our GCF is 16, 12, and 4. Well, 4 looks at the smallest number. Does 4 divide 12 and 16? It sure does, so that's the biggest number there. And then x cubed, x squared, and x, you got 1x. So our GCF is 4x. So you're thinking about taking this polynomial and you're dividing it all by that GCF of 4x. Once again, you can do one big divide sign or think about it as dividing each part individually. That may help you make sure you get all your steps down. 16 divided by 4 is 4. X cubed divided by x is x squared. 12 divided by 4 is 3. X squared divided by x is x. 4x divided by 4x is 1. So we're saying, hey, this polynomial is up top is equal to the remainder of what we got from our quotient times our GCF, which is 4x. Okay, let's look here. You want to think about what's your GCF. I've got a 5 and a 10, so my GCF definitely has a 5 in it. There's no x in this one, so we can't have x. I got x squared, x cubed, so y squared and y cubed, so y squared is the biggest one in common. So you're dividing each of these by your y squared, 5y squared. So 5 divided by 5 is 1. There's no x to cancel out on the bottom, so that just gives me x. You can, and y squared divided by y squared cancels, right? These two parts cancel. So you can write that as 1x, but that's the same as just x. And then we're adding 10 divided by 5 is 2. Y cubed divided by y squared is y. So we're saying, hey, it's the product of what we got as our remainder times our GCF of 5y squared. Okay, why don't you go ahead and pause the video? I want you to try these next 3 on your own.